Hi students, this video is on the chapter The Human Eye and the Colorful World Part 5. Now in this video let us discuss the important point, that is scattering of light. What is scattering of light? The reflection of light from an object in all directions is called as the scattering of light, or the phenomenon of absorption and re-emission of light by the medium particles is called as the scattering of light. The color of scattered light is depends upon the size of the scattering particles and the wavelength of the light. According to the Rayleigh scattering, when the size of the scattering particle is less than the wavelength of the light, the scattering of light is inversely proportional to the fourth power of the wavelength of the light. That means very fine particles scatter mainly blue light, while the particles of larger size scatter the light of longer wavelength as red light. So if the size of the scattering particle is large enough, then the scattering of light may even appear white. And now some phenomenon related to the scattering of light are the Tyndall effect. What is Tyndall effect? We have to discuss, and why the color of the sky is blue, and the color of sun at sunrise and sunset is red. So all these three important phenomena related to the scattering of light we have to discuss here. The first one, what is the Tyndall effect? When a beam of light passes through a colloidal solution, the path of light becomes visible due to the scattering of light by the colloidal particles. This is known as the Tyndall effect. The Earth's atmosphere contains air molecules, water droplets, dust, smoke, etc. When the sunlight passes through the atmosphere, the path of the light becomes visible due to the scattering of light by these particles. The color of the scattered light is depends upon the size of the scattering particles, and very fine particles scatter the blue light, larger particles scatter the different colors of light, and this is all according to the Rayleigh scattering of light. The intensity of scattered light is inversely proportional to the fourth power of the wavelength of light. The blue color has minimum wavelength and red color has maximum wavelength. That means what? The blue scatters large, red scatters minimum. And the next phenomenon, why is the color of the uh, sky is blue? The fine particles in the atmosphere have size smaller than the wavelength of the visible light. They can scatter blue light which has a shorter wavelength than the red light which has longer wavelength. When a sunlight passes through the atmosphere, the fine particles in the atmosphere scatter the blue color more strongly than the red, and so the sky appears blue, and the large scattered blue light is enters to our eye. And it also should be noted that if the sky appears black to the passengers flying at higher altitude, because the scattering of light is not prominent at such height due to what? The absence of the particles. That means if the earth had no atmosphere, there would not be any scattering of light and the sky would appear dark. And why the cloud appears white in color? Cloud contains water droplets, dust particles, and ice crystals. The size of these molecules is greater than the wavelength of the light. So all the colors get scattered equally, therefore the cloud appears white. So the next phenomenon we have to discuss about why the color, why the what? The sun appears red during the sunrise and sunset. So what happens during the sunrise and sunset? The light rays from the sun passes through a greater part of the atmosphere. The most of the lower wavelengths are removed by scattering. The unscattered light, that is the longer wavelength, reaches the observer. Hence the sun appears reddish during sunrise and sunset, and this is again in accordance with the Rayleigh's law of scattering, that is intensity of the scattered light is inversely proportional to the fourth power of the wavelength of the light.